All right, guys, welcome back to today's notes. We are getting into the last section of notes for this unit that we've been working with parallel and perpendicular lines. I talked about this a little bit in class, but we're moving through this pretty quick. We just got a lot to get through this semester. So last section of notes will be today, then we'll work on the review and so on and so forth. So 3.5 is the notes for today, and that's going to be labeled Proving Lines Parallel. It's going to be very similar to the ideas that we talked about in the last notes with 3.4, except we're kind of changing the order of how we do things. And we'll talk about more about what that we'll talk more about what that will look like. So day today is the 5th, if you'd like to add that. And the objective for today is we want to use theorems and postulates to prove that lines are parallel. Last time we were told that they were parallel from the start. Now our end goal is to prove that they're parallel. And as I discussed, we'll talk more about what that'll look like as we go through these here. So first off, little review. I won't make you sketch this down or anything like that. And here, I'll pull this up a little bit. But if I'm looking at this diagram here, I want to use this to fill in the blank. So I have this here. Oops. I think I muted myself. But we're going to use this to fill in the blank here. So if I have this, I'm saying if A is parallel to B, then there's something that I know, then blank, because of the alternate interior angles theorem. So this is similar to what we talked about last time. We're trying to use this. We're saying, okay, if I know that these lines are parallel, what do I know about some of the angles in that picture? And then what is my reason for that? And we're told in this case the reason is the alternate interior angles theorem. So if I'm looking at this picture and I'm trying to find the alternate interior angles, well, I know 3 and 6 are alternate interior angles. And then I also know 5 and 8 are alternate interior angles. So if I'm trying to fill in this blank, if A is parallel to B, then what do I know about these angles? Well, the alternate interior angles theorem tells me they're going to be congruent. So I can say then angle 3 is congruent to angle 6. And I do want you to write this piece down. So I want you to write the statement, if A is parallel to B, then 3 is congruent to 6. And angle 4 is congruent to angle 5. Okay, and the reason for that, like it says, is because of the alternate interior angles theorem. So still using what we talked about last time, go from parallel lines to now what information do we have about the angles. For today, like I said, we're trying to switch that order around. So instead of being told, here's my lines, now I can say something about the angles, I'm reversing it. I'm saying, here's something about the angles, now what does that tell me about the lines? And we have, just like yesterday, or just like last class, we have different theorems and postulates to go with this. So first one here they're going to use is called the converse of the corresponding angles postulate. Converse of corresponding angles postulate. And remember, and so I'll give you a sec to write that down. And remember that word converse is what we learned in Unit 3 when we said we take the hypothesis and the conclusion of a statement, of an if-then statement, and switch the order. And that's exactly what we're doing here. So converse of corresponding angles postulate says this. It says if both pairs of corresponding angles, between lines and a transversal so again, we're still thinking of this same kind of diagram that we've seen before, except now we're not necessarily told that the lines are parallel. So we're saying if I look at a diagram like that and I see both pairs of corresponding angles between lines and a transversal are congruent, then the lines are parallel. The lines are parallel. And we'll draw a picture with this to kind of visualize what we're talking about here. If both pairs of corresponding angles between two lines and a transversal are congruent, which is what they should be, then I know the lines are parallel. Okay, otherwise we wouldn't be able to say that they're parallel. So if I look at this here to kind of see how this changes, let's say we have two lines, and these could look parallel. These might look like they have the same slope or that they'll never intersect, but I don't know that for sure because I don't have those little arrows like we had on that diagram up here, those little pink arrows, right? So if I'm looking at this here and I'm trying to figure out what could prove that they are parallel, let's say if I have angle 1 and angle 2 here, and we say if angle 1 is congruent to angle 2, then let's say we'll call this A and B here. Then I'll say line A is parallel to line B. A is parallel to B. Okay, this is the order of our statements now. Now that we know that the corresponding angles are congruent, that means that the lines have to be parallel. So we do that same kind of thing for the other ones here, and we'll only write a few of these, kind of like before. So the next one we have here is the converse of alternate interior angles theorem. And the converse of alternate interior angles theorem says this. It says if both pairs, because remember there are multiple pairs here, or I should say really, I guess it doesn't matter if it's both pairs. I'm going to say if a pair of alternate interior angles between lines and a transversal, kind of a mouthful, but we have to describe what's happening here. So if I look at these lines, the same diagram, lines cut by a transversal, and if I look and I see the alternate interior angles are, remember we're just going to use the same thing. What should they be? What has our theorems told us before? Well, if they're parallel, then they should be congruent. So I'm going to say if those lines are, or if those angles, excuse me, are congruent. I'll write this down here. Are congruent. Then what do I know about the lines themselves? Well, then I know that the lines have to be parallel. So I'm going to say then the lines are parallel. Okay, this is the big piece that we're going for again. Does the information fit what it should? Are the alternate interior angles congruent, or are they the same measure? Because it's possible for me to have a diagram like this where they could look, the two lines could look parallel, but if the angles don't match up with that, then those lines cannot be parallel unless I'm told that specifically. So again, if I want a diagram here, move myself up a little bit. Let's draw the same two lines, A and B, and notice I'm not adding anything on them, so I don't know whether these are parallel yet. Let's say here, and we'll go, just to stay consistent, angle 3 and angle 4. And notice I would need to know that if I was told or proven somehow that angle 3 is congruent to angle 4, if I just prove one of those pairs, then I can now say that the two lines are parallel. And that would be our end goal. Then A is parallel to B. Okay? Next one here, and this will be the last one that we write out completely. And we'll draw a diagram like this as well because I want you guys to make sure you have something in your notes to go back to. The converse of same side interior angles theorem says this. It says if a pair of same side interior angles are, okay, and remember we have to ask ourselves this question, what are they supposed to be? Well, usually when we see if the lines are parallel, then the same side interior angles, remember same side goes with supplementary. So these angles should be supplementary here. So we'll say if the same side interior angles, and I guess I need to add this piece between, we need to make sure we are describing the full situation. So between lines and a transversal. Between lines and a transversal are, like we said, they should be supplementary. Then same ending as always. Then the lines are going to be parallel. So I'll say then the lines are parallel. Okay, so that would be my statement there. If a pair of same side interior angles between lines and transversal are supplementary, if they fit what they should be, then the lines have to be parallel. So last diagram we'll draw here. I know it's kind of wordy and it takes some time to kind of go through all these, but it is important to have these diagrams with you because they'll just help that or make it that much easier as you're working on these problems. So let's draw our same diagram and then let's just choose two same side interior angles. So remember, inside of the lines, same side of the transversal. So if I look at 5 and 6, notice what I would have to say here is I have to be told they're supplementary. And it's very important that we understand it's supplementary, not necessarily an equation that they add up to 180. That piece that I have to get to is I have to say that they're supplementary. So I'm going to say if angle 5 and angle 6 are supplementary, then A is parallel to B. Okay, I'm going to circle that or mark that off a little bit because that is important. Okay, notice I'm not trying to show, and I would use this in a proof as well, I'm not trying to show that they add up to 180 or there's an equation that equals 180. I'm trying to just say they are supplementary, the actual statement itself. Okay, and then for the last couple here, if you'd like to, you can just say converse of alternate exterior angles theorem, and you can abbreviate that as needed. But all we're going to write for this is same as before. We're going to say it's similar to the alternate interior, or I'm sorry, the converse of the alternate interior angles theorem. So I'm going to write it like this. I'm going to say converse of interior angles theorem. I'm sorry, I need to add the alternate as well. The alternate interior angles theorem. Okay, just a way to abbreviate that. So it's the exact same theorem, so I'm not going to make you write it again. The only difference is you change the word interior to exterior. So no use in writing the whole thing. And then last one here, converse of same side exterior angles theorem. Very similar to what we've already talked about. So I'm going to say similar to converse of same side interior angles theorem. It's the exact same theorem. If I show that the exterior angles are supplementary, then I can say that the lines are parallel. It's the exact same thing, except the only thing I change is the word from interior to exterior. Okay, so that is the idea with these kinds of theorems, and the good news is that we can use these to try to work through all these different proofs here. Okay, so with that in mind, let's do this. Get to some examples. First one here, example 1. We have a similar kind of diagram. I do want you to take a sec. I want you to sketch this down in your notes with all the points that they have there and where those angles go, and then we'll come back together. So hopefully you have this written down here. And one of the biggest things I want you to notice in this case is notice these lines right here are not parallel. Okay, they're not parallel. I know that because they don't have those little arrows on them. So that's what I'm going to try to show here is I'm saying I want to find x that would make that true. What would x have to be so that ML is parallel to PN? Well, the good news is the setup of these problems is still the same. I'm saying I would treat it as if they're parallel and show what x would have to be to make that true. So if these lines were parallel and I see these two angles here, first thing I need to think of is what kind of angles do I have here? Well, we call these, they're on alternate sides of the transversal, and they're both on the interior of the line. So these are alternate interior angles, and what is supposed to be true about them if the lines are parallel? Well, they're supposed to be congruent, or the same. So that's exactly how I'm going to set up my equation, is I'm going to set it up as if they should be equal, or should be congruent. So 5x plus 7 should equal 7x minus 21. And whatever I find for x here, that would, if that was actually x, then that would show that these lines are parallel. So once we have this set up, we're going to solve like normal here. So I know I have 5x on both sides, so I can subtract that. When I do that, I'm left with 7 equals 2x minus 21. Continue to solve, add 21 to both sides. When I do that, these cancel. And then I have on the left side 7 plus 21, which is 28. And that equals 2x. And then hopefully we understand our last step here is to divide by that number in front of the variable. I'll bring my answer over here. X is going to equal 28 divided by 2, or just cut in half, which would be 14. And this would be my final answer here. So notice it's as if I gave you a problem where the lines were parallel. It's the same steps. The only difference is I'm going into it not knowing whether the lines are parallel, and I need to show what should X be to make that true. Okay, so really the work itself is not any different. It's just the idea behind it that changes a little bit. And that helps us because that's going to change how we set up and solve these proofs here. Okay, so I'll scroll down here, move myself to the side just for a second. So this will be example 2. I do want you to pause your video and I want you to sketch this diagram here. And I do want you to write a piece down for this as well. I do want you to write this statement. I want you to write it under example 2. I want you to say use the converse of corresponding angles postulate. You don't need to worry about the given and the proof, but I do want you to write that, and I'll explain why in just a second. Okay, so hopefully you've gotten that all written down. The reason that I had you write down that first piece, I want to use the converse of corresponding angles postulate, is because on these problems there's multiple theorems or postulates that you could use at the very end to show that the lines are parallel. I'm going to tell you which one I want you to use on a lot of these problems that we do either today or in our homework. So I want you to pay attention to that and use that. Okay, and that tells you your last reason that you're always going to use. So for example here, if I have this diagram, you should have this drawn out. I'm given that angle 1 and angle 2 are supplementary, and then I want to try to show with that information that L is parallel to M. So what I'm going to do here, since this is a proof, or I'm trying to prove this, is set up my two columns, statements and reasons as always. Okay, and hopefully we understand, we should know by now, first reason is always the same. I'm always doing the same thing. I'm just writing down my given. And in this case, my given is that 1 and 2 are supplementary. So angle 1 and angle 2 are supplementary here. Okay, I'm going to need some extra space. I'm going to have to kind of crunch these down a little bit. So if I just gave you this and I didn't tell you which theorem to use or postulate to use, and I just said, prove that these lines are parallel, we could jump to that immediately, and we could just immediately say these lines are parallel because of what we call the converse of same side interior angles. Because we've shown 1 and 2 are supplementary, and that's that condition that we have to meet to say, all right, I know these lines are parallel. And then I just have to ask myself what kind of angles I have there. But notice it's not telling me to do that. It's telling me to use the corresponding angle, or I'm sorry, the converse of corresponding angles postulate. So what that means is I have to do something here with angles 1 and angles 3. And I have to show something in this problem. So how I'm going to do that is, notice I can't just jump to say and immediately say 1 is congruent to 3. I would be able to do that if I knew that the lines were parallel. But since I haven't proven that, I can't connect 1 and 3 that way. So I have to use something else. I have to use angle 2 in here. So all this mumbo jumbo to say, how do we get through this proof? Well, first question we always need to ask ourselves, especially when we don't have any variables or algebra problems to kind of bail us out. First question you always need to ask is, do I know anything from my given information? So right here we've said 1 and 2 are supplementary. So do I know anything from that, or how am I going to proceed with this? Well, if they're supplementary, we know that means that they add up to 180. So that's exactly what I'm going to say, is I'm going to say measure of angle 1 plus measure of angle 2 equals 180 here. Okay, that's the first thing I'm going to say. What is my reason for that? How do I know that? Well, that's just what it means for angles to be supplementary. That's just the definition. So I'm going to say definition of supplementary angles. Okay, first piece that I needed to write down. I know that they're supplementary, which means I know they add up to 180. All right, so that's the first thing we always do. Look at our given. Next thing, if we can't get anything more from our given information, is we ask, do I know anything from my diagram? Do I know anything just by looking at my diagram? And like we've said, I can't say anything about 1 and 3 because that would have to mean that the lines are parallel. I'd have to be told that already. So, but I can see here, if I look at 2 and 3, I do know information about 2 and 3. Remember, they're on the same line and they're right next to each other. So this is what we call a linear pair. And so this is exactly what I'm going to say, is I'm going to say angle 2 and angle 3 form a linear pair. Angle 2 and angle 3 form a linear pair. They fit that description or the definition of it. So my reasoning that goes along with this, and I know it's kind of hard sometimes to keep track of all these different definitions and postulates and theorems, but the reasoning here is just the definition of a linear pair. It fits that description. It's the same thing that we talked about when we were talking about vertical angles. It fits that description, so it's just by definition. So definition of linear pair. All right. So now we've used our given, we've used our diagram, and now we have to look at our statements and ask, how can I proceed? Do I know any extra information? Well, if we look at the one that we just wrote down, we said angle 2 and angle 3 form a linear pair, which means we know what about them. Okay, we know that they add up to 180. So in this case, I'm going to say angle 2, and I'll say measure of angle 2 plus the measure of angle 3 equals 180. All right, and what is my reason for that? How do I know that? This is not going to be definition of supplementary angles. If you put that, I wouldn't, count off too much or anything like that. But remember, this actually goes with our theorem, which we said is if I see a diagram that fits that description, and I've said they're a linear pair, then they're supplementary, or they add up to 180. And this is what we call the supplement theorem. So this is the case where you use the supplement theorem, is when you have a diagram that goes with it. If I just told you they're supplementary, then you use the definition. Okay, and we can talk more about those little nuances. Like I said, if you don't get that little nuance, as long as you put something with supplementary, that's really what I care about. But it's just trying to be as accurate as possible. Okay, so we have this here, we have all this information. Now we're trying to use these statements to come up with our final steps, which is trying to get to say 1 is congruent to 3, and then these lines are parallel. So the way I'm going to do that is, notice here, I've said this whole expression is equal to 180, and this whole expression is equal to 180. And we've talked about this before. If two expressions or if two numbers equal the same thing, then they equal each other. If A equals B and B equals C, then A equals C. So I'm going to say this expression here, measure of angle 1 plus measure of angle 2, the top one, okay, equals the same thing that 180 also equals, which is measure of angle 2 plus measure of angle 3. Like I said, we've talked about this before. We've seen this before. What's my reasoning behind that? How do I know that? Well, I would accept one of two things. Number one, that property that we talked about, which says if A equals B and B equals C, then A equals C. That would be the transitive property. Okay, transitive property of equality here. If you do not say that, if you said substitution, I would also accept substitution. So since one thing equals 180, I can just plug it in for 180 wherever I see it. All right, and now we're going to continue to solve this here. We're almost done. We're getting very close. Or I'd say getting close to proving it, not necessarily solving it. So we have this here. We want to get to a point where we're saying something about corresponding angles. So we want to say something about 1 and 3. Well, right now we can't do that because 2 is in there and it's on both sides. But since it's on both sides of the equation, if I just get rid of that, or in other words, in algebra, if we subtract it, then I'll just be left with 1 and 3. So if I subtract this from both sides, measure of angle 2 from both sides, on the left side I would be left with measure of angle 1, and on the right side I would be left with measure of angle 3. And the question is, how did we get here? Well, the reason we know that is because of the subtraction property. I subtracted something from both sides. Okay, we could throw in a step in the middle there and have to say that measure of angle 2 is equal to itself, but I'm not going to worry about that as of right now, just so we can get through this proof a little bit quicker and not worry about it so much. Okay, so we have this here. We've said measure of angle 1 equals measure of angle 3, and we know that we're supposed to use the converse of corresponding angles postulate. And stay with me, guys. I know it's been a long proof. But if I scroll up here, notice what we have to fit to say that, to use this converse of corresponding angles postulate, notice we have to say that two corresponding angles are congruent. Right now in our proof, we've said that they're equal, so that last little piece before we can get to our final statement is we need to say that they are congruent. So angle 1 is congruent to angle 3. Angle 1 is congruent to angle 3. And what is my reason for that? My reason, anytime we go from equals to congruent, is just definition of congruence. Definition of congruence. So this has been a long proof, and I've done all these steps and used all this information to get to this point where I've shown that two angles that are in the same spot are congruent. And now that fits that property or that postulate that we talked about, which is called the converse of corresponding angles postulate. Since the angles are congruent like they should be, that means I know that the lines are parallel. So I'm going to say line L is parallel to line M. And what is my reason for that? Well, I was already told what that postulate was going to be. That is the converse of the corresponding angles postulate here. Okay, just like it told me at the beginning of the problem. I'm using the converse of corresponding angles postulate. Okay, so again, a little bit more work and it takes a little bit more time, but still the same idea. I need to show something about the angles, and if I show something about the angles, then I can say something about the lines here. Okay, and let me check the time. It looks like we're running pretty low on time here, and that was a long proof in general. So what I'm going to have you guys do is I'll have you guys stop here, and then let's just say this. We'll just do example 3 in class together, because again, these ones can kind of be kind of confusing. But I do want to get through this example because you'll see some of these kinds of problems on your homework. So I want you to practice that a little bit. Okay, so stop here. You can just let me know in class when you're done. I'll give you guys like a time limit, and then we will do example 3 together before you move on to your homework. If you're in the morning, then just obviously stop here, and then when you come into class, we'll work on example 3 to start off. Okay? All right. If you have any questions, as always, please let me know in class. Thanks, guys.